Amtrak's high-speed train, the Acela, utilizes the tilt of cars when negotiating curves. The angle of the tilt is adjusted so that the main force exerted on the passengers to provide the centripetal acceleration is the normal force. The passengers experience less friction force against the seat, thus feeling more comfortable. Consider an Acela train that rounds a curve with a radius of 620 meters at a speed of 160 kilometers per hour, approximately 100 miles per hour. Part A. Calculate the friction force needed on a train passenger of mass of 75 kilograms if the track is not banked and the train does not tilt. So the first thing that you are going to do is you are going to draw the train. You can draw it from a top view as if you were looking down upon the train rounding the curve, or you can look at it from the front as if you were looking right at the train. So in your free body diagram, you're going to draw it as if you were looking straight at the train. You have a normal force pushing up upon the train from the track, you have a force of gravity pushing down upon the train, and you have a centrifugal force or the friction force. In this case, since it is a straight track, the things will be equal. Next, you can write down what you know about the problem so far. So, the mass of the passenger is 75 kilograms, the radius of the turn is 620 meters, and you know that the velocity is 160 kilometers per hour. Now, because we know our velocity in kilometers per hour, we are going to want to convert that to meters per second, since that is what velocity is normally measured in. Then once we have that conversion, we can set up our equation of sigma f equals the mass times the acceleration of the circle. We know that our acceleration of a circle is equal to the velocity squared divided by the radius. Therefore, when you plug in each of these values, you come out to the friction force being 238.9 newtons. Part B. Calculate the friction force on the passenger if the train tilts to its maximum tilt of 8 degrees toward the center of the curve. So the first thing that you're going to do in this problem is draw the free body diagram. In this case, our train is tilted 8 degrees inward towards the center of the circle. Therefore, you draw your 8 degrees in an acute angle, and you draw the train on top of that 8-degree angle. Then you're going to draw your normal force pushing upwards upon the train from the track, and you're going to put your force of gravity directly down. Now, the normal force lies upon the y-axis, so it does not need to be broken up into components. However, the force of gravity is not, so it needs to be broken up into two different components, the force of gravity on the x and the force of gravity on the y. Then you have your centripetal force and your friction force. In the other problem, part A, these were the same thing because the train was straight on the track and did not have a tilted angle. But in this problem, since there is a tilted angle, they are different, where the centripetal force is pointing directly into the circle, but the friction force is pointing on the x-axis. Therefore, your friction force, since it lies on the x-axis, does not have to be broken up into components. However, like the force of gravity, your centripetal force needs to be broken up. And so this makes up your free body diagram. So now that you have your free body diagram, you can use it along with your previous knowledge from this problem to break up your components and find their numerical values. In this way, you know that your centripetal force of x is equal to the centripetal force times cosine of 8, and your centripetal force of y is equal to the centripetal force times sine of 8. And you know from the previous problem that your centripetal force is equal to 238.9. So when you multiply those together, you get your components of the centripetal force. Next, you have your components for the force of gravity. Your force of gravity on the x is equal to force of gravity times the sine of 8, and your force of gravity on the y is equal to your force of gravity times cosine of 8. Now, you know that your force of gravity is equal to mass times gravity, which equals 735. So when you multiply those out, you have your force of gravity components. So then after we've written down this information, we can use our equations to find the force of friction. So we're going to use the equation all of the forces on the x is equal to mass times acceleration on the x. So you have your friction force plus your force of centripetal force on the x plus your force of gravity on the x is equal to mass times velocity squared over r. Then, since you've done all of these calculations already, you can plug them in and you'll be able to get your force of friction equaling 100.5 newtons.